Okay, class, so today it's a shorter topic. We're looking at the special angles 30, 45 and 60 degrees. We would have touched on this and we would have looked at them at page 13, the start of the trigonometry section of the Formula and Tables book. So you will have seen how to get the sine, cos and tan of these three angles from your Formula and Tables book, but we also need to know where they come from, how we derive those special angles. So we're going to start off with a construction. So here I have my equilateral triangle. It has three equal sides, three angles, all 60 degrees. We will be covering the construction of this at a later time in class, but for now let's investigate it. So the first thing I want to do here is drop a vertical. So we've dropped a vertical from the top down to the base, and that creates this right angle triangle. And as we know, the angles of this will be 60, 90 and leaving 30 degrees up here at the top. So this suits us really well because now we can investigate the angles of 60 degrees and 30 degrees. Okay, so those are my angles. And I'm going to pull out this triangle now so I can isolate it and take a closer look. So you see there that we have that the third side, the vertical that I dropped down has a measure of root 3. So where does that come from? It comes from Pythagoras' theorem. So I know that a squared plus b squared is equal to c squared. So let's call that a. This is b and this is c. So I didn't know what b was. I found it to be root 3 by just dropping in the root 3 there, but let's see where that comes from. So 1 squared plus b squared is equal to 2 squared. B squared is equal to 4 minus 1. So b squared is 3. That means b is root 3. So that's where that root 3 comes from. Okay, so now that we know what the measure of all our three sides are, let's look at our special angles. So we can use SOHCAHTOA. So SOHCAHTOA, and that's what we use to tell us what the sine, cos and tan of a given angle in a right angle triangle is. Okay, so let's look at the 30 degree angle here first of all. So we know that the sine of 30 degrees here is going to be the opposite over the hypotenuse. So sine 30 degrees is a half. The cos of 30 degrees then will be the adjacent side. This is the side that's adjacent to 30 over hypotenuse. So that's going to be root 3 over 2 for the cos of 30 degrees. And then finally the tan is opposite over adjacent. That's the opposite side 1 over the adjacent side root 3. So 1 over root 3 is the tan of 30 degrees. Okay, let's look at 60 degrees next. So root 3 over 2 is the sine of 60 degrees. Where does that come from? So here's my 60 degree angle. The opposite side is root 3. The hypotenuse is 2. So that's where our opposite over hypotenuse comes from. Cos of 60 degrees then is going to be adjacent over hypotenuse, which is a half. And then the tan will be opposite over adjacent. That's root 3 over 1. And let's look at where that comes from. The opposite is root 3. The adjacent to 60 degrees is 1, so it's just root 3. Okay, so to investigate my last angle, which is 45 degrees, I need to construct a new triangle. This is an isosceles triangle. This is a right-angled isosceles triangle. So one of the angles is 90 degrees, and so the other two angles must be 45 degrees each. And I've made the two sides of this triangle 1. So what will the hypotenuse be? So using Pythagoras' theorem again, a squared plus b squared is c squared. A is 1, so 1 squared plus 1 squared is c squared. 2 is c squared, so c is equal to the square root of 2. Okay. So we will be looking at this construction later on. And one of the things you need to know for the Leaving Cert is how to construct a length of root 2. And this is how you would do it using a right angle triangle where each of the other two sides is 1. And so let's use that now to get the sine, cos and tan of a 45-degree angle. Okay, so sine, first of all, sine is going to be opposite over a hypotenuse. So this is 45 degrees. The opposite is 1. The hypotenuse is root 2. So the sine of 45 degrees is 1 over root 2. Okay, the cos then of 45 degrees is going to be the adjacent, which is 1, over the hypotenuse, which is root 2. So sine of 45 degrees and cos of 45 degrees are both 1 over root 2. And then finally the tan is going to be the opposite over the adjacent, which is 1 divided by 1, which is just 1. Okay, and as I mentioned before, all of these ratios are on page 13 of your Formula and Tables book. And so if you're ever asked to find the sine, cos or tan of these angles in surd form, you use that page 13. Surds are square roots that are not rational. Okay, so the likes of root 3 and root 2, and they can be useful in working out given trigonometric equations. So we'll look at a couple of examples. Okay, so let's just do a quick few examples to practice using these ratios. I'm going to do these ones down here on the left hand side first. The cos of 150 degrees. I'm going to do a tan and a sine as well. So the cos of 150 degrees, I don't want to use my calculator. I want to use one of my angles here. It means I'm going to have to use my reference angle over here at 180 degrees. So this is 180 degrees. And remember, we can use the unit circle, and we know that this is the x-axis and this is the y-axis, so we can use any part of the x-axis to take our reference angle from, either the positive side, which is the side we normally take our angles from. We normally measure them from here. This is 0 degrees and we go around in an anti-clockwise direction, but we can also use this side. So we can take our reference angle from over here on the 180 degree angle. So this is 150 degrees, so let's draw it in. Okay, now I know that that's not very accurate, but I want to give myself space here to make that a 30-degree angle. Okay, so if this is 150 degrees, it's making a 30-degree angle with the reference arm here, which is at 180 degrees. Okay, so let's look at what the cos of 30 degrees is. So the cos of 30 degrees, I get it here. Where's 30 degrees? Here's 30 degrees. The cos of 30 degrees is root 3 over 2. So I'm going to have a root 3 over 2 anyway. And now I have to decide if that's going to be positive or negative. So I know from using CAST or C-A-S-T that in this part of the unit circle, in the second quadrant, that sine is positive, but cos and tan are negative. So that means that I have a negative root 3 over 2 is my answer. Let's look at tan of minus pi over 6 now. Okay, so I'm going to clear my unit circle now. And I'm going to look at minus pi over 6. So because this is a minus pi, it means that I'm reading my angle in the clockwise direction. So I'm starting here at 1, 0, okay, or at 0 degrees. And I'm going to be reading it now in this clockwise direction. So I'm going to go pi over 6 that way. Okay, so let's read our angle. So a tan of pi over 6 is tan of 30 degrees, or pi over 6 here. The tan of that is 1 over root 3. Okay, and thinking again about CAST, C-A-S-T, tan is negative here in this quadrant, in the fourth quadrant, so my answer is minus 1 over root 3. And then finally, I have the sine of 7 pi over 4. So let's really think about what 7 pi over 4 is. It's quite a big angle, so it's quite close. We've gone most of the way around the unit circle, so we're quite close to 2 pi. So instead of thinking about how many degrees or how many radians I've gone around the circle, maybe I should think about using a reference angle from this direction, from the minus direction. So if I think of 2 pi, I'm going to write it over here. So 2 pi minus 7 pi over 4 will tell me what my reference angle is. So that is equal to, if I change 2 pi into quarters, it's 8 pi over 4 minus 7 pi over 4, which leaves me with pi over 4. So that's my reference angle. So it's going to be another reference angle in this fourth quadrant here. I'm going to get rid of what I have there. Okay, so this is going to be an angle of pi over 4. And so what is the sine of pi over 4? Give myself a small bit of room here. Sine of pi over 4, but it's minus pi over 4 because I've gone in the anti-clockwise direction. That is going to be, well, the sine of pi over 4, let's look on our table here. Sine of pi over 4 is 1 over root 2. And then I need to decide whether this should be negative or positive, and only cos is positive in this quadrant. So sine is going to be negative, so it's minus 1 over root 2 is my answer. And then finally, let's look up here at the last question, which is sine squared of pi over 6 plus sec squared of pi over 3. Okay, so there's a couple of things we need to talk about here. First of all, let's talk about sec and cosec. So let me highlight these on your formula tables. Up here on the left-hand side, you can see we've tan A and cotan sec A and cosec A. So sec A is just 1 over the cosine. Cosec A is 1 over the sine. And that's always there in your formula tables for you to refer back to if you ever forget those identities. So I have a sine squared of pi over 6. Now all that means is get the sine, different colour, get the sine of pi over 6, whatever that is, and square it. Okay, but we put the square here after the sine because we want to say that we're squaring the sine of the angle. We're not squaring the angle, we're squaring the sine of the angle, so we write it as sine squared pi over 6 as opposed to this business here with the brackets. This is the conventional way of writing that. This is the way that you might be more familiar with, that will make sense to you in terms of brackets and powers. Okay, so sine squared pi over 6 is the same thing as square whatever the answer to sine of pi over 6 is. And then it's the same with sec squared pi over 3. We'll get the sec of pi over 3 and then we'll square it. So the sine of pi over 6 is here. It's a half. So I'm going to do a half to be squared plus the sec of pi over 3. Okay, so pi over 3. Let's find the cosine of pi over 3 first of all. So the cosine of pi over 3 is also a half. Okay, so 1 over half is the sec of pi over 3. And we've got to square that. That is a half squared. We can make that a quarter. Half squared is a quarter. Plus 1 over half is the same thing as 2 over 1 to be squared. So I get a quarter plus 4, which is 4 1/4.